Look up at the night sky. Every human who has ever lived has gazed at these same stars, asking the same questions. Where did we come from? Are we alone? What lies in the deepest corners of space? For the first time in human history, we have built a machine capable of answering these questions. This is the story of the James Webb Space Telescope, humanity's greatest window to the cosmos. The human story of Webb begins not in space, but in the minds of dreamers. In 1989, as the Hubble Space Telescope was preparing for launch, a group of scientists gathered to discuss what would come next. They knew that even Hubble, as revolutionary as it would be, couldn't see the universe's earliest moments. The light from cosmic dawn, stretched by the expanding universe, would be invisible to Hubble's eyes. They needed something different, something that could see in infrared light, operating at temperatures near absolute zero. Imagine folding a tennis court-sized spacecraft like origami, launching it 1,000,000 miles into space, then unfolding it perfectly to capture light that has traveled for over 13 billion years. This was the challenge that faced thousands of scientists and engineers for 3 decades. Their goal wasn't just to build a better telescope, it was to create a time machine that could peer back to when the first stars began to shine. The scale of the challenge was unprecedented. The telescope would need a mirror 6 times larger than Hubble's, yet light enough to launch into space. It would need to operate at temperatures colder than any natural point in our solar system while part of it basked in eternal sunlight. Every component would have to work perfectly the first time, 1,000,000 miles from Earth where no repair mission could ever reach. Behind these technical challenges were human stories. Engineers who spent their entire careers solving seemingly impossible problems. Scientists who dedicated decades to a project they might never see completed. Young graduates who joined the team with stars in their eyes, growing gray while wrestling with the complexities of building humanity's most ambitious scientific instrument. The mirror alone was a testament to human ingenuity. 18 hexagonal segments, each coated in gold just atoms thick, had to work together as a single, perfect reflector. The gold layer on each segment is so thin that if you unfolded it, it would be too thin to make a human hair golden. Yet these mirrors had to be shaped with precision beyond anything attempted before. If Webb's primary mirror were scaled to the size of the United States, no bump would be taller than a 1/4 inch. But the mirrors were just the beginning. To see the faint infrared light from the early universe, Webb's instruments needed to be incredibly cold. The solution was a sunshield the size of a tennis court but thinner than a human hair. Made of 5 layers of a material called kapton, each layer would be separated by a vacuum gap, creating a temperature difference of over 300 degrees Celsius from one side to the other. This engineering marvel would protect Webb's sensitive instruments from the heat of the sun, Earth, and even the moon. The precision required was almost beyond comprehension. Webb's instruments would be sensitive enough to detect the heat of a bumblebee on the moon. The mirrors would have to be aligned with accuracy greater than the wavelength of the light they were collecting. The sunshield would have to unfold in space without tangling, despite having over 1,400 pins and trigger points. As the years passed, the cost grew. $10 billion, a number that sounds astronomical until you put it in perspective. It's less than what humanity spends on coffee every 3 months. Less than the cost of a single aircraft carrier. A bargain, perhaps, for a machine that could revolutionize our understanding of the universe. December 25, 2021. After years of delays and setbacks, Webb finally sits atop an Ariane 5 rocket in French Guiana. The hopes and dreams of thousands ride with it into the darkness. The launch must be perfect, even a slight deviation could spell disaster. 27 minutes of controlled explosion hurling $10 billion of scientific ambition into space. In mission control, the tension is palpable. 30 years of work, countless careers, and humanity's greatest astronomical ambitions all rest on these crucial moments. The rocket ignites, and Webb begins its journey. Every second feels like an eternity as the spacecraft climbs higher, each milestone bringing both relief and new anxiety. First stage separation. Second stage ignition. Payload fairing jettison. Each step perfect, each moment bringing Webb closer to its destiny. But launch was just the beginning of Webb's transformation. Like a butterfly emerging from its chrysalis, Webb had to undergo a metamorphosis more complex than any spacecraft before it. There were 344 single points of failure, 344 ways things could go catastrophically wrong. No aspect of this deployment had ever been attempted in space before. Day by day, Webb began to unfold. First, the solar array deployed, giving Webb the power it needed for its journey. Then the main antenna boom extended, establishing the communication link that would send Webb's discoveries back to Earth. Next came the most critical and complex part, deploying the massive sunshield. The sunshield deployment alone involved 107 release mechanisms, all of which had to work perfectly. Like a celestial origami master, Webb slowly unfolded its protective layers. Each step was monitored by engineers on Earth, who could only watch and wait as signals traveling at the speed of light brought news of success or failure. As the sunshield deployed, Webb's temperature began to plummet. The cold side of the telescope would eventually reach -233 degrees Celsius, while the sun-facing side remained at a toasty 85 degrees. This extreme temperature difference was essential. Without it, Webb's own heat would blind it to the faint infrared light it was designed to detect. Then came the mirrors. One by one, the 18 hexagonal segments moved into position. Each segment had to be aligned with precision greater than the wavelength of the light they would collect. Using special actuators, engineers on Earth could adjust each segment's position by increments smaller than a wavelength of light. After 30 days of deployment and 6 months of cooling and calibration, Webb was ready to open its eyes to the universe. The first images arrived in July 2022, and they exceeded every expectation. In a patch of sky no larger than a grain of sand held at arm's length, Webb revealed thousands of galaxies, each containing billions of stars. Light that had traveled for over 13 billion years finally found its home in Webb's golden mirrors. This first deep field image was just the beginning. Webb turned its gaze to the Carina Nebula, a stellar nursery where new stars and planets are being born. Through its infrared eyes, Webb pierced the cosmic dust clouds that had hidden these processes from view. The image revealed hundreds of previously unknown stars and countless protoplanetary systems where new worlds are forming. In the Southern Ring Nebula, Webb captured the death throes of a star similar to what our Sun will become in the distant future. Its unprecedented resolution showed details never seen before, including shells of gas and dust ejected by the dying star. This wasn't just a pretty picture, it was a glimpse into our solar system's fate billions of years from now. Webb's study of Stephan's quintet revealed 5 galaxies locked in a cosmic dance that has lasted for billions of years. The telescope's infrared vision showed not just the galaxies themselves, but the complex interactions between them, vast clouds of gas and dust being pulled and stretched by gravitational forces, triggering the birth of new stars. But perhaps Webb's most exciting capabilities lie in its ability to study exoplanets, worlds orbiting other stars. By analyzing the way starlight filters through these planets' atmospheres, Webb can determine their chemical composition. This breakthrough capability brings us closer than ever to answering one of humanity's most profound questions: are we alone in the universe? Every day, Webb streams 57 gigabits of data back to Earth. Each bit carries a piece of our cosmic story, the tale of how atoms forged in the hearts of stars came together to form planets, oceans, and eventually, us. We are made of star stuff, and Webb helps us understand our own cosmic origins. The telescope's discoveries have already challenged our understanding of the early universe. Webb has observed galaxies from a time when the universe was less than 300 million years old, an epoch previously hidden from our view. These observations suggest that galaxy formation began earlier than our theories predicted, forcing astronomers to revise their models of cosmic evolution. In our own cosmic backyard, Webb has provided unprecedented views of our solar system neighbors. It has studied the complex chemistry in Mars' atmosphere, captured detailed images of Jupiter's storms and auroras, and observed the mysterious methane seas on Saturn's moon Titan. These observations demonstrate Webb's versatility, proving it to be not just a deep space observatory, but a powerful tool for understanding our celestial neighbors. Webb's impact extends far beyond astronomy. The technologies developed for the telescope are finding applications in medicine, industry, and everyday life. The advanced sensors developed for Webb are being adapted for use in cancer detection. The sophisticated software created to process Webb's images is advancing fields from artificial intelligence to automated manufacturing. But perhaps Webb's greatest achievement isn't just scientific, it's human. In a world often divided, Webb represents what we can achieve when we work together. Scientists and engineers from 14 countries spent over 3 decades solving impossible problems. They pushed the boundaries of human knowledge and engineering, not for profit or power, but for the simple desire to understand our place in the cosmos. The precision engineering required for Webb has advanced our capabilities in countless areas. The techniques developed to shape Webb's mirrors are now being used to create more precise optical components for everything from satellite communications to laser surgery. The thermal management systems designed for Webb's sunshield are inspiring new approaches to energy efficiency on Earth. Each image Webb sends back is a reminder of our cosmic heritage. When we look at Webb's image of the Carina Nebula, we're seeing the process that created our own solar system some 4.6 billion years ago. When we study the atmospheres of distant exoplanets, we're learning about the conditions that might lead to life elsewhere in the universe. When we peer into ancient galaxies, we're witnessing the processes that created the elements that make up our bodies. The James Webb Space Telescope cost each human on Earth about the price of a cup of coffee. In return, it's giving us our first clear look at the cosmic dawn, helping us understand where we came from and perhaps where we're going. It's showing us galaxies that existed before our planet was born, stars being born and dying, and planets that might harbor life. As Webb continues its mission, floating silently in the darkness of space, it reminds us of something profound about human nature. We are explorers, dreamers, wanderers. When we look up at the night sky, we're driven to understand what we see. Webb is the latest chapter in humanity's oldest story, our quest to understand our place in the cosmos. The discoveries keep coming. Webb has found evidence of organic molecules in the atmospheres of distant planets, spotted the earliest galaxies ever observed, and revealed new details about the formation of stars and planetary systems. Each observation adds another piece to the cosmic puzzle, helping us understand how the universe evolved from the simplicity of the early cosmos to the complexity we see today. The telescope's observations have also provided new insights into dark matter and dark energy, the mysterious components that make up most of the universe but can't be directly observed. By studying how galaxies cluster and move, Webb is helping astronomers map the invisible scaffolding of the cosmos. For the next generation of scientists and engineers, Webb is more than a telescope, it's an inspiration. Young people looking at Webb's images aren't just seeing pretty pictures, They're seeing proof that with dedication, cooperation, and innovative thinking, humanity can achieve things that once seemed impossible. Every time you look up at the night sky, remember that out there, a million miles away, Webb's golden mirrors are capturing ancient light from the farthest reaches of space and time. Each photon it collects is another piece in the grand puzzle of our cosmic origins. Through Webb's eyes, we're seeing the universe as it's never been seen before, answering questions that have haunted us since we first looked up at the stars. The images Webb sends back aren't just scientific data, they're portraits of our cosmic family album. The swirling clouds of the Carina Nebula, the delicate shells of the Southern Ring Nebula, the interacting galaxies of Stephan's quintet, these are the processes that created us, that continue to shape our cosmic environment, that connect us to the vast tapestry of space and time. Webb's mission is expected to last at least 5 to 10 years, but it carries enough fuel for potentially 20 years of operation. Each day brings new possibilities, from finding potentially habitable worlds to witnessing the formation of the first galaxies, from understanding dark matter to uncovering the mysteries of cosmic evolution. This is more than a story about a telescope. It's a story about human curiosity, ingenuity, and cooperation. It's about our eternal quest to understand our origins and our place in the vast cosmic ocean. Through Webb, we're not just reaching for the stars, we're finally touching the light of cosmic dawn. As we continue to receive Webb's discoveries, we're writing new chapters in humanity's greatest story, the story of our universe, our origins, and our future. Each image, each data point, each discovery adds to our understanding of where we came from and helps us contemplate where we might be going. As you contemplate the images Webb sends back to Earth, remember that you're not just looking at pretty pictures. You're looking at your own origins, written in light that has traveled across billions of years just to reach us. In Webb's mirrors, we see not just distant galaxies and newborn stars, but reflections of our own boundless curiosity and unwavering spirit of discovery. The story of Webb is still being written. Each day brings new discoveries, new mysteries, new questions to answer. But one thing is certain, we are living in a golden age of discovery, seeing things no human has ever seen before. And through Webb's eyes, we're all explorers of the cosmic frontier. Look up at the night sky again. Thanks to Webb, we're beginning to understand what we see up there. We're witnessing the moments after cosmic dawn, seeing the light from the first galaxies, and perhaps finding signs of life on distant worlds. This is our universe, our story, our cosmic legacy. And we're just beginning to understand it. Through Webb's golden eyes, we're not just observing the universe, we're discovering our place within it, one photon at a time.